So remember when you are graphing a system of linear equations, if both lines cross at one spot, one unique solution, we say that that is consistent and independent. We have intersecting lines, we have one solution where they intersect. Then if you have a system that's consistent and dependent, that means it's the same line, in which case there's infinitely many solutions. It's all the points on the line. That is not the same as all real numbers, because there's a whole bunch of points outside of the line that are not solutions. Okay, so infinitely many solutions. If you have parallel lines, we say that is an inconsistent system and there is no solution. Now, the drawback, we've done finding systems or solving systems by graphing, and the drawback to this method is that you can't always tell where the two lines cross. So there's a limitation. You have to you can if we do it on the graphing calculator, and I will show you how, but otherwise it's not the best way. However, algebraically, we have a way that we can solve a system of equations. And the first method we're going to learn about today is called the substitution method. What you do is you're going to solve one equation for one of the variables. It can either be solved for y or it can be solved for x. And then you're going to substitute the resulting expression into the other equation to replace the variable, and then you'll solve the equation, and then you'll substitute to solve for the other variable. Now, if you're not sure what those steps mean, I'm going to show you. In the first example, you don't have to do step one because the equations are already solved for one variable. So if y equals 2x plus 4, and at the same time y also equals 2/3 x minus 2, then it must be true that 2x plus 4 equals 2/3 x minus 2. So I'm making that substitution. So this is what you do if both equations are already solved for one single variable. Now my next step at this point is I want to solve for x, and I want to get rid of the fraction. So I'm going to do fraction busters, multiply everything by a 3, and when I do that, I'm going to get 6x plus 12. Here, because there's nothing to cancel. Here the 3's cancel, leaves me a 2x. Nothing cancels, so this is minus 6. So that was just to make it a little easier without the fractions. So next I'm subtracting 2x from both sides. And I'm going to subtract 12 from both sides. So I get 4x equals negative 18. So x equals negative 18/4, or negative 9/2. Now, that's just the x value. I still need to find out what y is. So here what you can do is, it doesn't matter, you're going to substitute, which is why it's the substitution method. You're going to substitute this value, negative 9/2, into either equation. I'm going to do the first one. We have a negative 9/2, so I'm just substituting this in. You've done that before. The 2's cancel. Negative 9 plus 4 is negative 5. So my solution is negative 9/2, comma, negative 5, which means if I graphed these two equations, they're going to intersect at that point. Actually, I'm going to go ahead and show you on the calculator. If you go to the spot to graph, y equals, I'm going to graph 2x plus 4, and then in y2, I'm going to graph 2/3 x minus 2. So if I do zoom 6, that will do a standard viewing window, negative 10 to 10 in both directions. I chose to do this with the one that has the color so you can see. And remember, our solution is negative 9/2, negative 5. So that makes sense that it would be in that quadrant. So can your calculator tell you the answer? Yes. If you go second, calc, and then you'll notice number 5 says intersect. You can either hit number 5 or scroll down to intersect. And then your calculator will ask you first curve because it wants to know if that's on the first curve. What I usually do is just move the cursor down close to the intersecting spot because it's going to need to be there anyway. You don't have to be right on it. So is this the first curve? Yes. And I know you might go, it's a line. Well, it's still considered a curve. Is this the second curve? It's moved to the red one. Yes. Make a guess. Well, as long as you're close to the point of intersection, you can just hit enter and look at the answer. Negative 4.5, comma, negative 5. So you can use your graphing calculator to verify your answers algebraically. And notice that in order to use your calculator, you have to have the equation solved for y. If they were in standard form instead of slope-intercept form, you wouldn't be able to do that. All right, so let's take a look at another example. So on this one, solve the system. Oh, this is a practice. So you can pause the video and practice this and see if you can get the answer. So you're going to set these equal to each other. So we'll have 1/2 x plus 1 equals negative 5x. Then I'm going to do fraction busters with a 2. So when I do that, the 2's cancel, leaves me an x. Nothing cancels here, so I just have to multiply. Nothing cancels here, so I have a negative 10x because there was nothing in the denominator to cancel with that 2. All right, so then I'm going to get the x's on the same side, so I'm going to add 10x to both sides and subtract 2. So I get 11x equals negative 2. So x equals negative 2/11. Sorry, got all these fractions going on. So then we're going to substitute that value. I'm actually going to do it into the bottom equation now. It doesn't matter which one. As a matter of fact, you should get the same answer no matter which one you substitute it into. So then you're going to just multiply and you get a positive 10/11. So my solution is negative 2/11, 10/11. Again, what that means is if I graphed these two lines, they are going to cross at the point negative 2/11, 10/11. So for this next one, it's a little different. Notice that only one of them is solved for y and the other one is in standard form. If you want, you can solve this one for y and put them equal to each other, but that's not the easiest way. When one of them is solved and the other is not, we're going to substitute. So what I'm going to do is I'm going to take this 2x minus 1, and since it equals y, I'm going to replace the y with a 2x minus 1. So then what my equation will look like is 5x minus 3, and then in place of the y, I'm going to put the 2x minus 1 equals 8. So notice that's the only thing I've done. The only change is I've replaced the y with a 2x minus 1. I've substituted, thus the name substitution method. Now you're still going to have to distribute here, so we get 5x minus 6x. That's going to make this a plus 3 when I distribute, equals 8. So we get negative x, I'm going to go ahead and subtract the 3 at the same time, is 5. Well, if the opposite of x is 5, then x equals negative 5. And you can get that by multiplying both sides by negative 1. Remember, you're not done yet. You have to find out what y is. Now in this case, it's easier to plug it into the first equation because that one's already solved for y. So I'm going to drop a negative 5 where the x is, and I get negative 11. So the solution is negative 5, negative 11. So I could graph both of these. Now, on your calculator, you would have to solve this for y in order to use your calculator to graph it. You can do it, and you could verify that the two lines would intersect at negative 5, negative 11. So why don't you try this one? So pause the video, try it. Okay, now this one is solved for x. It doesn't matter which variable it is, it's still a single variable. So it's going to get dropped in here where the x is instead. So I have a 2, and instead of an x, I'm going to drop in a 3y plus 4. And then I have a plus y equals 12. So I'll distribute the 2. We get 6y plus 8 plus y equals 12. So 7y, I'm going to go ahead and subtract the 8, and I get 4. So y equals 4/7. But we need x also. Again, I'm going to use the top equation because that one's already solved for x, which means it's a little easier. Remember, this is like having 3 over 1. So multiplying fractions, I multiply the numerators. So I get 12. 1 times 7 is 7. You can use your calculator if you need to. Finding a common denominator, that makes this a 28 plus 12. So that's 40 over 7. So my solution is 40/7, comma, 4/7. And that's where the 2 lines would cross. Now to graph this one, you can't set up your calculator. Your particular calculator will only graph y equals. It won't graph x equals. So you would have to do it that way if you were using your calculator. All right, next one. So what would I do on this? Neither one of them are solved for a variable. Probably what I would do, there's a lot of different ways you could do this one. I think I would solve, I'm going to solve them both for y, because notice that it's just plus y, and this one is plus y. So it'd be pretty easy just to say y equals, if I subtract the 2/3 x, I'm going to have negative 2/3 x plus a half. Okay, so I've just subtracted the negative 2/3, chose it to put it first, so it's in slope-intercept form. Wouldn't have to. Subtract x, so I get negative x plus 4. And now I have them both solved for y, so I can set them equal to each other. So this is back to that first method that I showed you. So on here, I'm going to do fraction busters to clear out these fractions. So that's going to make this a 6. So when I multiply by 6, the 3 cancels with the 6, leaves a 2, times negative 2 gives me a negative 4x. Here the 2 cancels, leaves me a 3, times 1 is 3. Here there's nothing to cancel on this side, so I just multiply. So I'm going to add 6x to both sides and subtract 3 from both sides. So I have 2x equals 21. So I get x equals 21/2. I'm really kind of into fractions today, I guess, huh? And then I have to solve for y. I'm going to choose to use the bottom one because it doesn't involve a fraction already. So x plus y equals 4, which means x equals, actually, let me change that part there. So y equals 4 minus x. So y equals 4 minus, plug in a 21/2. This, and you can get your calculator out, I don't care if you do. So I have 8/2 minus 21/2. So I have to do 8 minus 21. So I get negative 13/2. So these lines cross at the point 21/2, negative 13/2. So that's your solution. Okay? Go ahead and try this one. So pause the video and try it. All right. So probably on this one, I would solve, I think I'm going to solve for x. Now, notice that I'm kind of, I don't know which way I'm going to do, because there's not a right or wrong answer. I mean, sometimes there's an easier way. I wouldn't solve the second equation for y because I'm going to end up with fractions right off the bat, and if I can avoid that, I'm going to. So notice with this one, I get x equals 4 minus 3y, and then I can take this 4 minus 3y and drop it into the other equation for x. So I'm going to replace the x with 4 minus 3y. So I get 2 times 4 minus 3y and then I have a minus y still, equals 5. So I've just substituted in place of the x, this 4 minus 3y. Then I have to distribute, combine like terms, and I get negative 7y equals, when I subtract, I'm going to get negative 3. So y equals, a negative divided by a negative is positive, so we get 3/7. Another fraction. And now I'm going to solve for x, and I'm going to use this right here. So x equals 4 minus 3 times 3/7, which is 4 minus 9/7. And if I find a common denominator, I get 28 minus 9, which is 19/7. So that's x. So x is 19/7, y is 3/7. And if you left it like that, you know, y is 3/7, x is 19, that's okay. The nice thing about the ordered pair is it reminds you that this is where the two lines would cross. Now, I noticed I didn't do any examples where you get a no solution or you get something that's always true. That could come up. If you are working out a problem and you get something that's no solution, that's your indication. If the two lines don't cross, they must be parallel. And if you work something out and you get something like 5 equals 5 and it's always true, you get a statement that's always true, that tells you that that you have the same line, and that would tell you that there are infinite solutions. So those could come up, so watch out for those. But that is how you do solving systems of linear equations by substitution.